Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and afternoon everyone. Okay, so siapa yang baru masuk tu boleh sign in attendance. Okay, so before I close the sharing for the attendance code here. Lagi 6 orang tak masuk, but I don't think we're going to wait. Alright, they will come in hopefully afterwards. Okay. Because you all have class kan nanti pukul 3. So quite rushing. Alright, so semua dah sign attendance. Siapa yang dah masuk ni? 25 of you now. So there are another 5. Devendran dah masuk belum? Are you here, Devendran?
Yes, I'm here.
Our new student? Yes. Alright.
Yes.
Devendran, can you show your face for the first time? So you are from Penang, right?
Yeah, I'm from Penang.
Buka video boleh tak? Request ni. So you sign your attendance. Alright, that is Devendran. Okay, yes. And if you want to know more about Devendran, you can share the. Kenapa muka you macam tu, Devendran? Okay, baju putih. Okay, nampak pun sebab you pakai phone. Alright. Okay. Want to know more about him? You can go to our Padlet. I think Devendran has updated his biodata there. And Devendran also, if you want to know more about your friends, you can read out through the Padlet and then you have all their numbers, kan? Alright. Okay, so Devendran, so welcome on board. So basically, Devendran, for our class, we have 3 hours class, 2 hours class on Sunday. I'll make it synchronous. Asynchronous meaning I've recorded the video and you are going to view the video when I upload it at the Google Classroom. And every Wednesday for 1 hour, we're going to have our synchronous class, meaning that we're going to have online class through WebEx like this, okay? But it is recorded. So meaning to say you still can view this. Hopefully the recorded video goes out, comes out well, then I can upload it at Google Classroom. Okay, so there are 28 of you now. So I'm going to close this I'm going to close this QR code, then I'm going to share with you the lecture notes. So everyone, apa khabar semua? Clear Semua?
Clear.
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 So semua dah tutup video hari ni. Okay. Alright. So Devendra, if you have limit on bandwidth, you can close your video now lah. Okay. Alright. Okay. Thank you. Alright. Okay. So I stop sharing sekejap. Then. Okay. Oh no, I'm gonna share lagi. Share with something else. Any this. Alright. Okay, class. So we continue from our asynchronous class on Sunday. Okay, well we have started with new chapter, right? Chapter 2, limits and continuity. Okay, so Devendran, hopefully you can catch up lah because I think you diploma, maybe some of the content you have learned before, I assume. I think so. Okay, so for this chapter 2, limits and continuity, okay, by checking on the task that I have given to you for the rest of the class that I asked you to submit, but still there are, I think 2 of you, 3, perhaps including the vendor is okay. Okay, still not submit, but the rest, okay, seems that you have done the 2 examples that I asked you to submit. And one question, I think almost all of you got it right, but there is one question that I think I need to discuss with you. Okay, so basically in our asynchronous lecture last Sunday, we have discussed about what is the definition of limits, okay, one-sided limits up to limits law. Okay, kita dah discuss about this 3. And remember, okay, by now everyone should know, okay, D and E. Anyone can tell me what is D and E? Apa itu D and E?
Does not exist.
Mina?
Exist.
Apa dia? Exist? Louder please. Does not exist. Fake. Does not exist. Okay. So everyone clear now? So meaning that limit, it can be, you may have value of the limit, the value exists, or it can be does not exist. So bilakah limit does not exist, class? Anyone? Adib, saya nampak nama Adib je kat sini. Adib? Adib ada ke tak tu? Anyone? Anyone else? Nazifah?
Limit kiri dengan kanan tak sama.
Kiri dan kanan tak sama. Okay, limit from the left is not the same as limit from the right, kan? Okay, so that is so called, this is when the condition limit does not exist, alright? So one-sided limit meaning that we consider limit from the left and limit from the right, okay? So remember definition of limits, okay? Definition of limit, I just want to recap back here. This is the value of a function fx at x equals to 1, kan? You have a function fx kat sini. This is the value when x equals to 1. And this is the value of the limit when x approaching 1. Okay, by now you should able to make differentiate the difference between these two. Kalau macam ni, f1, we are finding the value of fx at x equals to 1 inside this, kan? And of course, you will get 0 over 0, meaning that this value does not exist. Tapi when we check limit of fx as x approaching 1, yes, we are substituting a value which is approaches 1 from the left, which is something the value which is very close to 1 but it is less than 1. Okay, 0.999 for example here, you can see the value converge to 0.5 here. And the same goes here when we substitute the value from the right, meaning that we substitute with a value which is something bigger than 1. Okay, but very close to 1, 1.001. Maybe you can substitute with 1.0001. So you can see also the value is converged to something similar, close to 0.5. So meaning to say this value is equals to 0.5. Limit as x approaching 1. Okay, so just a quick recap, and we have discussed this and this, okay, and this one, and this one, and I assign you to solve one question, okay, question number 1 for example 7, right? Okay, we're going to discuss this because when I check through your solution, not many of you got it correct. Okay, not many of you got it correct. So for oh sorry, lama sekejap eh. Okay. All right, so for this one, you can see for the graph gx graph below, find the following limits. Limit gx as x approaching 5. Many of you, what is your answer, class? Okay, when limit gx as x approaching 5 here. Anybody? You have the solution with you. I know your solution. Many of you say, what is your answer? Exists or does not exist limit of gx as x approaching 5? Exists or does not exist? Yung?
Does not exist.
Does not exist. Why are you saying does not exist? When,
Uh,
where is 5? Where is 5, class? Okay, x equals to 5. This is 4, kan? This is 4, this is 6. So 5 is here, right? 5 is here. So please look carefully here. So limit, when we want to check for limit gx as x approaching 5, meaning to say we need to check from both sides, kan? From both sides, limit of gx as x approaching 5 from the left. Okay, from the left, let's have a look at this curve. Maknanya kita nak cari value, we look as x approaching 5, we're looking on the defined curve here. Where is the curve coming? So when x equals to 5, okay, you see from the left, meaning that from the region where x is less than 5. So kita tengok dekat curve ni lah. So as x approaching 5 from the left, is pointing to what value here, class? What is this value? Is it does not exist here? This value is equals to 0. You see? And here, limit of gx as x approaching 5 from the right. From the right, maknanya dia datang daripada arah 5, x is more than 5. Okay, lagi besar daripada 5. Dia datang dari arah kanan. Okay, then it's pointing to what here? Also is pointing to 0. Faham tak? kita tengok dekat curve ni. Okay, we are finding to the curve. So maknanya, from the left of 5 is pointing to 0, from the right of 5 also is pointing to 0, meaning to say limit of GS as x approaching 5 is equals to 0. Faham? So that is the answer. Some of you got it correct, but many of you got it not correct. Okay. So for B, limit GS x approaching 9, yang ni I rasa semua orang betul. Exist ke does not exist? Class for B?
Does not exist.
Does not exist. Yes, this is very clear lah yang ni. Limit, okay. Limit. Okay, for this one, yes, it does not exist because limit from the, kat sini 9. Okay, so maknanya limit GX SX approaching 9 from the left, what is the value? From the left, you kena tengok graph je kat sini. Tak ada calculation pun. From the left is equals to 1. And from the right, limit GX SX approaching 9 from the right. What's the value from the right, class? Okay. 2, yes, correct. From 2 from the right. Maknanya kita looking from this curve. This is 9, from the right of 9, and is 2. So you can see this is does not equal. So limit GX as x approaching 9, yes, correct, it does not exist. What about limit GX as x approaching 4, class? Exist or does not exist? Limit GX as x approaching 4. Anyone? Nama siapa yang dah naik kat sini? Luqmanul
Exist.
Hakim. Exist or does not exist?
Saya jawab exist.
Awak jawab exist. Apa jawapan awak? If it is exist, what is the value then?
From the left side 4, from the right side 4.
Yes, correct, Luqman. So, meaning that this answer is equals to 4. Limit from the left, maknanya kita tengok walaupun dia berlubang kat sini, from the left is pointing to 4. Okay, this is from the left and this is from the right. So, it's also pointing to 4, meaning the answer is equals to 4. But if I ask you what is F4, what is the value? Is it equals to 4? What is the value for F4? Okay, when x equals to 4, the value is not equals to 4, tapi dia punya value is actually equals to what? Is
0.
equals to 0, correct. Ni nampak ni, point hitam secotek kat sini. Maknanya is defined here. Okay, is defined here. Point ni, okay, is defined at 4 here. Okay, nampak tak? It's point at 4 here. Alright, so that's the solution for the example that I asked you to do. Okay, and then the rest is fine. And everyone got answer correct here. What is the answer here? 11 over 10. Okay, the answer for this one is 11 over 10. That's good. Everyone got it correct. So I'm not going to discuss the solution. Tapi I have one example to discuss with you, one extra example, because it may help you later to solve the assignment question. So I'm giving you one example. It's not inside the notes now, class. Okay, limit t approaching 0 from the left, let's say, t over modulus t. Okay, t over modulus t. Can you see the soalan tu kan? Okay, t over modulus t. So, what do you think the solution here? The soalan, dia tanya soalan for one-sided limit, which is limit t approaching 0 from the left. So, everyone familiar with this symbol, modulus t? Apa maksud modulus t? Apa maksud modulus, class?
Always positive.
Yes, correct. Always positive. Okay, always positive. So, meaning to say, kalau always positive ni, maknanya, kalau value t ni less than 0, oh, sorry, saya nak sapu jap. Sapu balik saya tulis balik soalan. Okay, so the question is limit t approaching 0, t over modulus t. So, what is modulus t? Modulus t meaning to say, okay, kalau t, dia akan define as negative t if our value of t is less than 0, and it will become t if t more than 0. Agree with me? tak percaya kalau you masukkan T sama dengan negatif 2. Okay, if let's say T is equals to negative 2. So which function you are going to use? The first one here, the first one or the second one, class? If T equals to negative 2, for modulus T, kita akan guna which function? The first one or the second one?
First one.
The first
First
one.
one.
Okay, you need to multiply with negative, then it will come out positive T. Maknanya modulus T akan jadi sama dengan 2 because we choose the first one. This is meant for T less than 0. Okay, tinggal pula from the left kat sini. Okay, so my question for this soalan ni, soalan tambahan kat sini, limit T approaching 0 from the left. Okay, from the left meaning that, okay, ni T equals to 0. Ni from the right and this is from the left. Maknanya for this region, this is T more than 0. This is T less than 0. So if T approaching 0 from the left, meaning kita ambil yang mana? Nombor 1 ke nombor 2, kelas? Number 1 or number 2? From the left meaning
Number one.
Kenapa?
One.
Right? Number 1 meaning we choose what? Negative T. Kita akan pilih negative T. So nampak tak kat sini? So negative T, what we can do here, we can cancel. So what you will get the answer, class? Negative 1. Faham semua? Okay, so jangan pergi substitute T tu dengan kosong, you akan dapat 0 over 0. Then because we have T over negative T, then you may cancel the T, then you will get negative 1. Okay, so if let's say my question now is limit T approaching 0 from the right. So if it is from the right, then T over modulus T. So now will be apa, class? T approaching 0 from the right. T over, kita nak open up the modulus, kita akan jadi positif ke negatif T? Positive or negative T?
Positive.
Positive. So the answer for this limit will equals to 1. So now what can we conclude? Limit T approaching modulus T for T approaching 0. T approaching 0, not from the left or from the right. Exists or does not exist the limit?
Does not exist.
Yes, does not exist. Why? Because limit from the left is not the same as limit from the right. Okay, clear so far, everyone? Okay, so now we're gonna move. Okay, we're gonna move to the next one here. Okay, then only 2:18 baru kita nak masuk the next subtopic here. Infinite limits. Okay, infinite limit of a function. Apa maksud infinite here? Meaning that your limits, okay, the result of your limit, kalau sebelah ni we have a value of a limit, or maybe the value does not exist, right? The value become does not exist when limit from the left is not the same as limit from the right, okay? But for infinite limit, meaning that your limit exists, but the value is infinite. Meaning that the value is equals to infinity. The other value, it is equals to something, but the value is infinite. Maknanya the value is equals to infinity. Okay, for example, you can see at this curve, okay, this curve is y equals to 1 over x square. Okay, 1 over x square. So you can see limit as x approaching 0, okay, 0. Kita nampak curve ni, there's nothing, okay, but you can see as x approaching 0, berdesup dia naik ke atas. But it does not cross the y-axis. Maknanya dia tak ada value when x is equals to 0. From the left, okay, it goes up. Maknanya it's approaching infinity. And from the right also, as x approaching 0 from the right, as it is very close to y-axis, but it does not cross the y-axis. Meaning that is approaching infinity. Faham semua? This is what does it mean by infinite limit. Where this one is so you tak perlu nak hafal tau. In maths, there's no such thing to memorize. It's just that you need to understand sahaja. Okay, tak payah nak ingat infinite limit at infinity, macam mana. You just need to understand. Don't worry about things for you to remember. Okay, and then for this one, limit at infinity, maknanya we want to find out what is the value of the limit as x approaching infinity. May it be negative infinity or positive infinity. So you can see here, this one, limit as x approaching negative infinity for 1 over x square. Maksudnya kat mana ni? Ke arah sini. Kita tahu, okay, this one is our x approaching negative infinity. So maknanya 10,000, negatif 10,000, negatif sejuta, negatif 2.6 bilion ke berapa lah trillion whatsoever is approaching negative infinity. But you can see this curve, okay, this curve, it won't cross the x-axis, okay, but it's very close to the x-axis, meaning that the value is approaches 0. And in fact, you boleh pun nak masukkan ni value ni kan, kalau you boleh y equals to 1 over x square, you masukkan dengan value yang sangat besar, sejuta, 5 juta, 1 over 5 juta, 2.6 billion, kenapa saya guna 2.6 billion ini, okay, 10,000 billion, okay, then if you press your calculator, selagi calculator tu boleh letak nombor, you will get the value which is very small, 0.0000 something, so you know that it's approaching 0. Same goes here. As approaching 0 from as approaching positive infinity. Maknanya 1 over positive billion, trillion and so on. So you press the calculator, you akan 0.000 something, which is also close to 0. Okay? Okay, so that is so called as limit at infinity. Okay. So for this one, okay, for this one, meaning that this one is limit fx as x approaching a. Okay, limit fx as ni sama je macam yang kita discuss tadi lah, yang ni where the value is equals to infinity. Kalau yang ni, okay, a juga, but the curve is going down, meaning that it's negative infinity. What I say here, in both cases, the limit does not exist. What I mean by the limit does not exist here, meaning that it does not have finite value. Okay, does not have finite value. Okay, the finite value for this limit does not exist, but it is equals to infinity or negative infinity. Clear, everyone? Okay, all right. Then for this one, okay, you can see here on this curve, let's have a look at this curve. Okay, limit fx as okay, I'm referring to this curve, soalan ni referring to this curve. Alright, so find limit of fx as x approaching 1 from the left. Okay, x approaching 1 from the left. Okay, x approaching 1 from the left. Mana 1 kita? Ni 1. 1 from the left. So what you can see here, from the left, okay, from the left, only one side I want to check. Okay, we can see as x approaching 1, okay, it does not, this is x equals to 1, okay, as x approaching 1, it goes up. Okay, it goes up. Kita tak tahu dia berhenti di mana, but it goes up to the sky whatsoever lah. So meaning that this value is equals to infinity. Goes up. Maknanya positive infinity. Where for the second one here, negative 1 from the right. Kalau negative 1 from the right, so maknanya this is negative 1. From the right, maknanya from this side, goes down. So it goes down, meaning that this value is equals to negative infinity. Sebab dia ke bawah. Okay, dia ke bawah. And in the note here, I already showed to you limit fx as x approaching negative 1, not from the left or from the right, is equals to negative infinity. Why? Because it satisfies from the left, or sorry, this one from the right goes down, from the left also it goes down. So maknanya is equals to negative infinity. Dia hanya menghampiri negatif 1. Bila dia menghampiri negatif 1, it goes up. It goes down. The value goes down that we don't know is approaches apa, very big value. Okay. And the same goes here. I have written down here limit fs as s approaching 1. Okay. Is equals to positive infinity, meaning that limit from the right, limit from the left here, from the left of 1 is equals to limit from the right of 1 where it goes up to infinity as well. Okay, clear everyone? Okay, then I have an example here. I want you to show that this one tak ada kaitan dengan sekejap saya nak tukar. Alright, so for this one, how to show that limit of limit x approaching 1, okay, x over x square minus 1 is equals to infinity. You can just show it. Okay, how to show this, meaning that we can just simply show that limit from the left is the same as limit from the right. Okay, so we have shown just now. Okay, limit from the left is the same as limit from the right. Okay, so for this one, okay, I'm not sure whether have you ever heard about this word or not. Asymptote. Pernah dengar tak perkataan asymptote kelas? Das?
Pernah.
Semua orang ada tak ada yang keluar masuk dah.
Benar.
Azan, pernah dengar tak perkataan asymptote sebelum ni?
Benar.
Pernah ke tak?
Pernah.
Pernah ada.
Okay, Rafi nampak pernah. Yes, okay. So saya tak payah nak explain dah lah. Lagi mudah kerja saya. Okay, so maknanya line yang kita ada kat sini, okay, line yang ni is what we call as vertical asymptote. Okay, with the line for this case, for example, x equals to 1, x equals to negative 1. Yang ni adalah line yang kita panggil sebagai vertical asymptote yang mana graph kita, function kita will never cross this line but it just approaches this line. Okay, it just approaches this line. Okay, so limit fx, okay, vertical asymptote ni akan hadir, okay, for this one, limit fx as x approaching a result positive or negative infinity. Then meaning that x equals to a is so called as our vertical asymptote. Okay, or the limit approaching a from the right is equals to positive or negative infinity. Okay, or from the left is equals to positive, negative, infinity. Okay, quickly. Okay, kalau you tengok graph ni class, everybody agree with me. We have how many vertical asymptote here? Okay, kita ada line 2, right? X equals to negative 2, one of the line. Vertical tahu vertical is menegak. Okay, menegak. Line menegak here. Okay, x equals to negative 2. Okay, x equals to negative 2 is our vertical asymptote and x equals to 2 is equals also our vertical asymptote. You can see the curve, okay, is not crossing the line but it just approaches the line. Whereas we have another, this one, horizontal asymptote y approaches y equals to 0. Maknanya this line, di line yang mendatang, okay, that is the line where the curve is just approaches this horizontal line but it never cross. So this is so called as horizontal asymptote. Horizontal asymptote we're going to discuss next. Okay. Kita tengok dulu ni. Alright, for this one. Okay, we have the curve here. So determine the vertical asymptote. Can you make quickly class decide what is the vertical asymptote for this example A? Ni kalau keluar exam ke quiz ke bonus mark ni tak payah kira, tengok je apa jawapan dia kelas.
X equals to 1, x equals to 3.
Yes, correct. Okay, correct yung x equals to 1 and x equals to 3. Everybody agree? So the two vertical asymptote exist. For example, A is x equals to 1 and x equals to 3. How we say, you can see graphically, you can see the line here. Okay, this is x equals to 1 and this is the line x equals to 3, and you can see from the curve it never crossed the line x equals to 1 and x equals to 3, but it's just approaches. So meaning that these two lines are so called as vertical asymptote. Okay, so it is here listed on the step on how to determine the vertical asymptote. Okay, example 9 that we have here, we are not going to there's no graph given to you, but how can we determine the vertical asymptote of this function? Okay, of example A and example B. Are we going to plot or sketch the curve? Okay, ambil satu kerja pula if you want to sketch the curve for this one in order to determine the asymptote. But what you can do here, class, you can see here, what does the suggestion says here? Simplify the function fx. Let denominator equals to 0 where the limit approaches infinity. Okay, the value of x where the limit approaches infinity is the vertical asymptote. Or dipendekkan cerita, senang je. You tengok the denominator of a function and find what is the value that will make the denominator equals to 0. Okay, that will make the value equals to 0. Let's try A. So A very straightforward, right? You don't have x squared plus 4, you can't simplify. Okay, step number 1 is simplify. So there's no way for us to simplify for A. So what is the vertical asymptote for A, class? What makes the denominator equals to 0? X minus 3 equals to 0. So the vertical line, which is become the vertical asymptote for this function, is x equals to 3. Agree, everyone? Class?
Yeah.
Yes.
Okay.
Yeah.
And then for B, okay, you look for B, class. B, the function is x squared plus x minus 6 over x squared plus 2x minus 8. For this one, okay, first step here, it is mentioned simplify the function. We try to simplify. What I mean by simplify here, if you can factor, then we try to factor. So x squared plus x minus 6, kita kan boleh factor apa? Ni quadratic function. Do you agree with me? Okay, x squared plus x minus 6 is actually equals to x apa? X? X apa kat sini? Kat bawah ni pun is x minus or plus something times with x minus or plus with something. So x square plus x minus 6 apa dia? Macam mana nak buat, nak jadikan
2
dia
and
6?
3.
2 and 3, correct. So 2 and 3 here. So which one is plus, which one is minus? Plus, I think plus 3 minus 2. This is what you have learned before, right? So I'm not going to explain anymore how we get this. And what about x square plus 2x minus 8, class? Is equals to what?
4 and 2.
Yes, 4 and 2. So this is 4, this is 2. So this one is what?
Minus 2 plus 4.
Minus 2 plus?
Plus 4.
Correct. Okay, minus 2 and plus 4. Saya nak tukar warna jap. Okay, minus 2 and plus 4. So you can see, we factor. This first step, we try to simplify. Is there any way for us to simplify here? Yes, you can cancel x minus 2 and x minus 2 together. All right. So meaning that what makes the denominator here equals to 0?
Negative 4.
Negative 4. So meaning that for B here, the answer is the vertical asymptote exists at x equals to what, class? Negative 4. Clear, everyone? Okay. The vertical asymptote exists at x equals to negative 4. Okay, at x equals to negative 4. All right. Any questions so far? Okay, how we
Problem.
proceed? No? All right. And then this is ni very straightforward lah. Limits limits at infinity. Okay, limits at infinity meaning we have limit of fx as x approaches infinity. Okay, limits at infinity. Our value of x It's not finite, but it approaches infinity. Okay, it approaches infinity yang ni. Maknanya x kita tak tahu sama dengan berapa, but it's just go to the right. It just keep on moving to the right, but it never cross the line L here. It never cross the line L here. As x approach going up to the right, okay, move to the right, maknanya value value x tu makin bertambah besar, but the curve is never cross the line y equals to L. Then we say that our y equals to L is our horizontal asymptote. Okay, the line y equals to L is our horizontal asymptote. And then same also here, it goes down, it goes to the left. Our x value, let me as x approaching negative infinity, moving towards left, okay, to the left. It never crossed the line y equals to m. Okay, it never crossed the line y equals to m. Then we call the line y equals to m as a horizontal asymptote. Okay. And then kalau yang ni, kalau you biasa tengok, this is the graph for tangent inverse. Dulu masa SPM ke, masa STPM ke, masa diploma. This, the line, this example lah, y fx equals to tangent inverse x. So the line y equals to, okay, y equals to negative pi over 2 and y equals to pi over 2 is so-called as our horizontal asymptote. Because if you try to press the calculator, okay, what is the value for tangent pi over 2? Okay, go ahead and try it, then you will find infinite answer, right? Okay, so these two lines is so-called as a horizontal asymptote. Yang ni just untuk you faham je apa itu horizontal and vertical asymptote. Not much things to know. Okay, and then this one, semua infinity. Limit fx as x approaching infinity is also equals to infinity. Alright, so meaning that here lah. Okay, for this one, the function we have fx equals to x cubed. As x bigger, okay, maknanya dia proportionate, okay. As x become very big number, then the value of x also become a very big number. Limit fx as x approaching infinity is equals to infinity here. Alright, limit of x as x approaching infinity is equals to infinity. Same goes here. Limit of x as x approaching negative infinity, okay, is equals to negative infinity. Okay, so this is so-called as infinite limits at infinity. By the way, for this one, for x equals to x cubed, fx equals to x cubed, do we have vertical or horizontal asymptote class? Ada tak vertical or horizontal asymptotes? Can you see the curve is just simply approaching any value of x equals to something or y equals to something? For this line class, fx equals to x cubed? Iskandar kata no. Yes, correct Iskandar. No. There is no vertical or horizontal asymptote for this curve. Okay, because it keep on increasing, okay, there is no limit or it does not approaches any line, but it goes up to infinity. All right, clear everyone? Okay, so now let's try to discuss example 11. Okay, let's try to discuss example 11 here. Find the limits. Okay, find the limit for a limit of 3x plus 10 over x squared minus 3x plus 2 as x approaching infinity. As x approaching infinity. So yang ni, kalau, okay, soalan, okay, if the question asking you to find the limit as x approaching infinity or negative infinity, dia ada cara dia. Okay, this cara is only valid kalau x2 approaching positive or negative infinity. This is a hint here. Okay, divide the numerator and denominator by the highest power of x in the denominator. Okay, tu dia punya rules dia. So maknanya untuk solve ni senang je. Okay, you tengok kat sini for A, Tahu kan numerator yang atas, denominator yang bawah. So for example A here, but this method is only valid untuk limit approaches infinity. X approaches infinity. So for A, what is the highest power of denominator class? X power of what? Class?
X power 2.
Yes, X power of 2. So maknanya kat sini kita akan bahagi X over X power of 2 plus 10 over X power of 2. Okay, X square over X square minus 3X over X square plus 2 over X square. Okay. Clear everyone? So in this case, maksudnya bila you substitute, what you will get? 10 over X square ni you assume that is very big number. So 10 divided by a very big number, what you will get, class? You will get 0, right? 10 divided by a very big number, you will get 0. And then this one, you will get 3X over X square. So you will get, kat sini boleh potong, so you tinggal 3 over X. X here is also a very big number, so you will get 0. Okay, down here 2 over X square, 0 also. 3 over X also 0. But this one is X square over X square. What you will get, class? You will get 1. Betul tak? Because you can cancel. So the answer here, what you will get is 0 over 1. Then this one is equals to 0. The answer will equals to 0. Or saya boleh ajar you cara yang lagi senang sebenarnya. Cara yang lagi senang, instead of you bahagi dengan the highest power of denominator, you just tengok je what 3x plus 10. Yang mana, which term is bigger, 3x or 10? Class, for A, which one is bigger, 3x or 10? Class, ada respon tak ni? 3x or 10? Ni, saya nak tunjuk dekat you cara yang lagi senang kat sini. So, instead of you bahagi macam tu, you tengok on the numerator here, what is the bigger term, 3x and 10? With
3x.
3x kot.
Yeah. Kita tengok, because 10 ni adalah 10 times with x power of 0. Nampak tak? So, maknanya the degree of constant compared to 3x, 3x is bigger. Because x kat sini adalah x power of 1. Yang ni adalah x power of 0. Down here pula apa yang paling tinggi? X square, 3x ke 2? Yang bawah ni? X square, correct. Okay. So, what you can do here, okay, so you can cancel je. So, you will get limit x approaching infinity 3 over x. So 3 over x is 0 lah. Maknanya 3 bahagi dengan something a very big number. So it's going to be 0. What about B? Okay, for B pula limit x approaching infinity 4x cubed plus 1. So up here, apa value yang paling tinggi kat sini, atas ni? 4x cubed or 1? The numerator.
4x cube.
Yes, 4x cube. Bawah ni apa yang paling tinggi? Bawah ni kena careful sikit Allah. Bawah ni. Yang bawah ni. 2x cube plus with square root of 16x power of, 16x power of 6 plus with 1. Apa power yang paling tinggi kat sini, kelas? Are you with me?
16.
16. 16? No, we are looking for the power of x. The degree for power of x. Kat sini. Check power of x. Tak payah tengok dekat dia punya constant. Okay. Power of 3 ke power of 6 kat sini yang tinggi? Yang mana lagi tinggi?
Power of 6.
Power 6.
Power 6.
Everybody agree. Tapi you tengok apa yang kat power of 6 ni terkurung ni. Terkurung dengan apa ni?
Betul juga.
Square root. Power of 4.
Square root. So kalau you buka square root tu dia jadi apa?
Power of 3.
Kuasa 3.
Yes. So maknanya dia seri kat sini. We have 2x power of 3 plus yang tambah 1 ni tak payah hirau sebab it's very small compared to the term 16x power of 6. You agree? Because x later we are going to add, we are going to substitute with a very big number. Apalah sangat kalau you compare dengan 1 tu. Someone please mute. Saya dengar suara mak ke adik you all tu masuk sekali ni. Okay? Ke nak belajar sekali limit? Ajaklah. Okay, so 16 x power of 6 tu square root. So you open up the square root, it become apa? Square root of
4x
16x.
kuasa 3.
Yes, correct. 4x kuasa 3. 1 yang ni don't care sebab it's too small kalau you nak compare dengan 16 infinity power of 6. Compare dengan 1 tu, then you just forget it. Okay, so meaning that the answer for this, you will get limit x approaching infinity. You dapat 4x cube. Kat bawah dia jadi berapa ni? 6?
6x cube.
6x cube. Then you may cancel. So the answer here is equals to apa kelas?
2 over
2
3.
over 3. Faham semua? Okay, the answer will equals to 2 over 3. Okay, 2 over 3. Okay. And then for question number 2 ni sebenarnya determine the horizontal asymptote of fx. Dia sebenarnya soalan sama je dengan number 1 tu. But it's just that number 2 ni they twist the question. Instead of they're asking you to find the limit as x approaching infinity, but they ask you to find the horizontal asymptote. What does it mean by horizontal asymptote? Meaning that this one is that we need to find the limit of 3x squared minus 7 over x squared plus 5x as x approaching infinity. Nampak tak? Okay, so I think now you can quickly give me the answer, betul tak? What is the highest power for numerator for 2a? For 2a. What is the highest power here?
X square.
3, maknanya x square, so maknanya kita ambil hanya 3x square. Perkali untuk x, you have to ambil, you have to ambil. Ataupun you have to carry along with the power of x. And what is for the denominator here class? X square plus 5x. So, it's x square, right? Okay, so here, then you will get the answer, limit kat sini dah tinggal. Limit x approaching infinity, you will get is equals to 3. Faham tak? So the answer is 3, meaning that our horizontal asymptote for A, our horizontal asymptote is equals to y is equals to 3. Okay, y is equals to 3. Okay, y is equals to 3. Fx ni kan y. Okay, fx ni kan y. So y is equals to 3 is our horizontal asymptote. The line y equals to 3 is our horizontal asymptote. What about B class? What about B? Okay, saya nak kena sapu lah ni. Tapi sapu nanti ada masalah pula. I have to erase all. Sorry. Okay, so for this one, nanti you tengok recorded video kalau you tak sempat. This one is y equals, this one, the answer is y equals to 3. What about B class? Meaning that for B, you have to find limit x approaching infinity for x power 4 plus 7 over x power 5 plus x square minus x. Okay, so for this one, meaning that what is the highest power for the numerator here? Kita tengok highest power of the numerator x power 4 dengan 7. So of course yang mana lagi tinggi?
Power 4.
X power 4. Kalau ada constant sekali dengan dia, bawa sekali. Tapi yang ni tak ada constant. So you don't have to carry together. What about the down here, the denominator? X power of?
5.
Yes. So you will have this limit x approaching infinity Ni 1, yang ni adalah kuasa 1. So meaning that this is 1 over x. So 1 divided by infinity, then it's gonna be equals to 0. 1 bahagi infinity, always remember it's gonna be 0 because 1 divide a very big number, so it approaches 0. Then our line, our horizontal asymptote then is y equals to 0. Okay, y equals to 0 is our horizontal asymptote. Clear, class? So for example 11 now, today we discuss about on how to find the limit as x approaches infinity. Okay, as x approaches infinity. Kenapa Luqman Hakim? Faham ke nak tanya soalan tu? Angkat tangan tu.
Macam
Okay.
mana boleh dapat 1 per x tu?
Macam mana dapat apa?
1 per x.
1 per x. Because kat sini awak faham tak? Yang ni x power 4 plus 7. Yang ni paling, ni faham tak? Kita dapat x power 4 over x power of 5.
Faham? Yang ujung tu.
Faham? Okay, good. So limit x approaching infinity, x power of 4 over x power of 5. So yang ni boleh potong lah ni Luqman. X power of 4 dengan x power of 5 ni kan, ni tinggal kuasa 1, faham? Kan kalau x kuasa 2 bahagi dengan x kuasa 3, you dapat apa? Ni x kuasa 2 bahagi dengan x kuasa 3, dia sama dengan x kuasa 2 over x kuasa 2 darab dengan x kuasa 1. Agree? So you boleh potong dan you akan dapat 1 over x kat sini.
Faham
tak?
betul. Faham.
Okay. So you get 1 over x. So 1 over x tu gantilah x tu dengan infinity, then you will get 0. So for A, we get y equals to 3 for our horizontal asymptote. Then B is our y equals to 0 for B, horizontal asymptote. Okay. Okay, to end our class today, I want to give you satu lagi teknik untuk selesaikan limits ni. Okay, kalau tadi, tapi syarat dia, kalau yang ni, kalau soalan tu adalah as x approaching infinity. You boleh hanya tengok numerator apa power yang paling tinggi, denominator apa power yang paling tinggi, then you may cancel them, right? Okay. Tapi dengan syarat power of denominator tu kena lagi tinggi daripada power of numerator lah. Kalau tak, you kena bahagi the whole thing with the highest power of the denominator kat sini. Okay, ikut syarat ni. Okay, this one L'Hopital's rule, bukan hospital L'Hopital's rule. Okay, tak tahu lah orang mana Sepanyol ke apa, saya pun dah lupa. Ni adalah teknik untuk you selesaikan you punya limit kalau you come to the case where you try to direct substitute, masukkan x ke dalam function tu, you get 0 over 0, ataupun you get infinity over infinity, ataupun you get negative infinity over negative infinity. Faham tak? Bila you try masukkan value tu, you dapat 0 over 0, ataupun infinity over infinity, ataupun negative infinity over negative infinity, you boleh use this L'Hopital's rule. Apa maksud L'Hopital's rule ni? Okay. Kalau tadi numerator kita ambil highest power, denominator kita ambil highest power macam tu. Yang ni, when you want to solve the limit, you differentiate the numerator, then you differentiate also the denominator separately. Dan tengok, you boleh solve tak limit tu. Okay. So, untuk solve, ni, kita quickly try to solve this example. You tengok soalan ni Limit as x approaching 2, x square minus 2x over 8 minus 6x plus 2x. Okay kelas, kalau you cuba masukkan terus limit x approaching 2 ni, masukkan 2. 2 square tolak 2 times 2. Kat atas ni dapat berapa kelas? 8, 6 darab 2 tambah 2 square. Apa yang you dapat kat sini? Atas dia you akan dapat 0, bawah dia you akan dapat berapa? 8 tolak 12 tambah 4. Also you dapat 8 tolak 12 tambah
0.
0. So you get 0 over 0. So in this case maksudnya cukup syarat untuk awak apply L'Hopital's rule. Macam mana cara nak apply L'Hopital's rule ni? Okay. atas dia you differentiate. So you differentiate. Tahu kan differentiate pembezaan. X square minus 2x. You differentiate respect to x. Apa yang you dapat kelas?
X tolak 2.
2x tolak 2. Okay, 2x tolak 2. Siapa yang tak tahu nak differentiate, you boleh PM saya lepas ni 2x tolak 2. Down here, what do you get? 8 minus 6x plus x squared.
Negative
Differentiate.
6 plus 2x.
Negative 6 plus
2x.
2x. Okay, so you see class here, what we can do, we try to simplify. Okay, you try to simplify here. Wait, ada soalan tu ke ni kat sini? Betul tak soalan I buat ni kan? 6 2x minus 6. Okay, this one is x minus 1. So here we have 2x minus 1 and then here we have apa? Tak betul je ni. 2, kalau kat sini we have factor 2, so we have x minus 3 kat sini. Ni tak boleh factor ni, sekejap I double check sekejap. Betul. 2x minus 2. Okay. So you can see here class. Okay, so you can factor this 2 and 2 out. Then if you replace with 2, what you will get? If you replace with 2, you will get apa? Ni, x ni you masukkan dengan 2. So you do have 2 minus 1 and then 2 minus 3. So you will get the answer is equals to negative 1. Agree or not? You will get negative 1. Maknanya kita factor, kita differentiate, then you can simplify, or if you don't want to simplify also, you can to direct substitute with x equals to 2, then you will get equals to negative 1. Alright. For B also the same. Kalau you direct substitute, of course you can see here is equals to infinity over infinity. Tapi yang ni sebenarnya, kalau you, kalau yang ni maknanya you can directly differentiate 3x minus 5, you dapat apa kelas? Differentiate 3x minus 5, what do you get?
3.
3.
You differentiate 6x plus 8, you dapat?
6.
Directly, limit as x approaching infinity is 3 over 6 or 1 over 2. Okay, clear tak? Limit of a constant, ni satu lagi saya lupa nak cakap. Limit as x approaching 2, katakanlah is equals to 2. Maknanya, value dia limit ni 2 lah. Okay, is approaches a constant, then it remain a constant. Okay, and finally yang ni, C, quickly you have class with Dr. Sharif soon. Limit sin x over x. Kalau you substitute, sin kosong sama dengan berapa sin kosong? You press the calculator, sin 0 is 0. Okay, if you substitute here, you will get 0 over 0. So this is not allowed to happen. So you can use L'Hopital's rule, maknanya kita try to differentiate sin x. So if you differentiate sin x, what you will get class? Sin x, quick.
Cos X.
Ingat Cos X, correct. Cos X. And differentiate 1, you dapat, differentiate X, what you will get? Differentiate
1.
X is equals to 1. Then, substitute je lah. Cos kosong, limit X approaching 0, cos 0 over 1. Cos kosong sama dengan? Press calculator lah, tak tahu. Cos 1 over 1, so limit is equals to? Yes, 1. Okay, so sharp. Ada 1 minit lagi. Okay, so this is so called as the L'Hopital's rule. Bila we come to the situation where we have condition 0 over 0 or infinity over infinity ataupun negative infinity over negative infinity, you may apply this rule. Maksudnya function tu you differentiate dia punya numerator, you differentiate denominator. Then try to substitute with the value of x approaching apa tu kat dalam function tu. Then if you get the answer, then that is the correct answer. Or kalau example B tu differentiate, terus dapat jawapan. Ataupun sebenarnya B ni, if you want to use the method that we use tadi pun boleh. What is the highest power of numerator? 3x. Highest power of denominator? 6x. Maknanya 3x over 6x, cancel dapat juga 1/2. You can use both method. Alright class, so that's all for today class. Okay, kita discuss about asymptote, limits at infinity, infinite limit at infinity, and we end our class today is discussing on the technique on how to solve the limits for the case for 0 over 0 or infinity over infinity. Okay, alright, so for today, no take home task. Considering that all of you have to submit the assignment 1 by tomorrow night, kan? So, saya tak bagilah apa-apa task walaupun ada yang dah siap. Okay, free lah hari ni. Alright, so any questions? Saya tak perasan ada kat chat ni, ada soalan. But you have class at 3 o'clock. So, anything we can continue discuss at the WhatsApp group. Okay? Alright class, so that's all for today. See you in our asynchronous class next week, Sunday. Okay, thank you.
Thank you, Dokter.
Thank you, Doctor.
Thank you, Doktor.
Ada orang tanya soalan. Offline tanya. Boleh guna example 11 yang mana? Ya, Haflan. Boleh guna dalam example 11. If we substitute it equals to infinity over infinity, then you can try. But I think it might be a bit complicated lah because you have to differentiate. Alright? Okay, you may leave. The rest, semua dah pergi
Ya, ya.